Sounds good. Okay. Well, we are going to talk about biodiversity. So kind of in my last few sessions over the last couple of weeks, I've kind of gone over evolution, and I went to natural selection, and now we're going to talk about biodiversity today. So let's go ahead and get started. Give you a little quick overview of what the session is going to look at. Welcome, we're just getting started. Just going over the agenda here for this session. So I'm going to first start off talking about biodiversity, and then we'll have two kind of question and answer periods. So that's a great opportunity if you have a topic or maybe an activity or a lesson that you're struggling with, or you want a little bit more feedback or clear understanding about what the directions are asking you to do. That would be a great place for you to get that question answered right here. So we'll do biodiversity, we'll do our first round of questions, and then today I'm going to talk about discussion posts because it kind of goes with the last part of this semester that I'm going to be talking about. And then we'll end again with questions and any comments, feedback that you guys have before we end for today. So and that's what it's looking like. Okay, guys, let's get started. Biodiversity. Here's a big old number for you. Don't read this part. Right here, 8.7 million. You guys all see that? 8.7 million. What do you think that number means? So we're thinking about our topic. Of course, I give you the topic here, biodiversity, 8.7 million. What do you think that number stands for? And again, you can speak out loud, or you can use your chat, or just hang tight and we can go over it. I see a chat coming in. Not sure. Hey, thanks for giving that input. I hear you. 8.7. It could be lots of things, huh? Could be, I don't know, maybe somebody's talking about seconds, minutes, I don't know, people. Well, when we're talking about biodiversity, as it says in here, what do you think that number stands for? Is it the number of seconds you've been alive, the number of salmon eggs laid in a year? This number represents how many different species scientists believe are living here on Earth. 8.7 million different kinds of species. So now we're not just talking about, like humans, we're a species, Homo sapiens. We're not talking about just the number of humans, we're talking about the number of individual types of species, okay? So Homo sapien would be one example of a species. So scientists believe there are 8.7 million different species. Plus, this number could be even bigger because it's believed that 80% of the species are on land, and 91% of those living in the seas have not yet to be discovered. So we also have to take in consideration that, we haven't discovered everything. We haven't been to every inch of our planet. So we know that there are more species that still yet need to be discovered. We also know through evolution that there are new species that, can come about. We also know that extinction can take place and we can lose some of those species as well. So pretty incredible to think 8.7 million different types of species that we really know of. And then as we think about even more so that have not yet been discovered. So that's a pretty cool thing to think. Welcome, we're just getting started here. We're talking about biodiversity. Okay, so let's get to it. What is biodiversity? Anybody have any ideas? Biodiversity, use those decoding vocabulary skills. Biodiversity. See if you can break it down and maybe into some smaller sections. How would you define that? We've heard this word, parts of this word, and we use it in a variety of different ways. Biodiversity. Sometimes I feel like some of these science words, it's like, I know what it means, but how do you explain it, or how do you define it? Sometimes that can be a little bit tricky. Is my sound better? Sorry if that was a little too low. Good. Okay. If we're going to break this word down, so here's one of what I like to do when it comes to words that I'm a little bit unsure about, is I like to break it down. So we talk about vocabulary strategies. If we take this word biodiversity and we break that down, and you can probably see, you've probably heard this word before, diversity, and you've probably seen this bio here before. So lots of times when we find new words that we're kind of unsure about what the meaning is, we can take that word and break it down. So bio means life. So when we think about the biosphere, we're talking about all the life on Earth. If we talk about biology, we're talking about the study of life. Yeah, right there. I gave the two examples off the top of my head, and they're right there. Okay, the other word, diversity. Think about diversity. We hear that lots of times. You know, diversity means variety. So we put them together and we get biodiversity. So we get diversity of life. So when we're talking about biodiversity, we're talking about all of the different species that live here on our planet. Talking about plants, to little one-celled little organisms, to, you know, birds and zebras, all of the life here. Okay. Biodiversity is the variety of all living things. It includes plants, animals, microorganisms, and their interrelationships. Sometimes we just think about, you know, when we think about organisms, we just think of, you know, what we see, like the big ones, the big animals roaming around. But we also have to take in consideration things that we might not be able to see, like those tiny little, you know, bacteria and organisms that are so small you have to use a microscope to view them. And that's also included when we're talking about life on Earth. Okay, we're talking about the genes that they contain and also the ecosystems that they form. So you think about all of the organisms that live within an area, their habitat, they're creating this ecosystem, and there's relationships between them where they, you know, they rely on each other. In simple terms, the word biodiversity can be described as the variety of plants and animal species in the places that they live, which would be those ecosystems. An important aspect of biodiversity is that it's not always apparent what is connecting these organisms together, and sometimes we have to dig a little deeper to see how they're all kind of part of the circle. In other words, the ways in which they depend on one another for its survival. So you think about with, you know, food chains and food webs, if we were to take one of those species or those organisms, that group of organism out, everything falls. Everything is connected in together. Okay, I put this picture in here because, I mean, when we think about mushrooms, yeah, mushrooms are living. They are a living organism. They're a type of fungi. They're actually called, they're decomposers as we think about, you know, where they're at in the food chain. They live off of decaying or dead material. Again, that's good because it helps put that carbon back in. But it's kind of weird to think about. These are all different types of what we would say species of mushrooms. You know, who knew? So many different species here. That's why we got such biodiversity. Okay, let's talk a little bit about ecosystems. So ecosystems include all the populations of species that live in an area along with the physical factors in that environment. So we're talking about all of the species, and then we're talking about physical parts. So that could be, you know, if there's a water, there's a creek, a river, a lake, rocks, canyons, that kind of physical features. Populations do not interact only with each other, but they also interact with those non-living factors in the environment. When we think about non-living and living, we use the word abiotic and we use the word biotic. So when we talk about non-living things, those are abiotic factors, and that's going to be like the water. It's going to be the weather, the gas in the air. Those are all going to be non-living factors that you know, have an important part. So if you think about it, if there's no water in an ecosystem, the biotic, the living things, aren't going to be able to survive. Okay, so other examples of abiotic factors: air, water, soil, sunlight, temperature, and climate. So you think about all of those things are needed for these organisms to live. You know, if there's no soil, plants aren't going to be able to grow. Same thing with sunlight. Okay. Go the other way. Features of environment that are alive or once were alive are called biotic factors. So when we think about in an ecosystem, that could be worms, it could be the plants, it could be the humans. All of those different examples are what we would consider biotic, living. each organism in an ecosystem needs a place to live. And the place in which that organism lives is called its habitat. So you think about it, your habitat is your home, okay? So when we think about biodiversity, we're talking about all of the organisms, but we're also talking about the ecosystems as well that they live in. How do we measure biodiversity? How do we measure biodiversity? And you think about a scientist and they're trying to say, if, does this area have a lot of biodiversity? Is it, low biodiversity? An easy way, or the common way to measure biodiversity, is to count the total number of species living in a particular area. What do you guys think? Would you want to go, think about it, go to the desert and walk around for miles and miles and pick out and count every single type of different species that you find? That would be pretty darn hard. So what scientists like to do is they kind of like to look at it from that point of view and then kind of generalize it. So we think about tropical regions. These are areas that are warm year-round. Oh, let's unmute. Sorry, I lost you guys. Are we back on? Can you hear me? Can you see my screen now? Awesome. Okay, I apologize. I do not know what happened. I was there, everybody was there, and then all of a sudden it all went blank. So thanks for sticking around, you guys. We're back on. Okay, so we're talking about measuring biodiversity. So when we talk about tropical regions, these areas, thanks, sorry about that, I got bumped off. We're back on. In these areas, they're warm year-round. So you think about seasons, as you think about kind of summer to winter, I'm not looking forward to winter. You think about winter, there's not a lot of growth, right? We don't grow like lots of fruits and vegetables during the winter. We talk about organisms that hibernate in the winter. Things slow down in the winter. So these areas that are near the equator, they're warm year round. They also tend to get, lots of rainfall in certain areas like the rainforest. Temperate regions, which have warm summers, cold winters, have less biodiversity. And then regions that are cold or really dry conditions, such as, mountaintops, the tundra, deserts, have even less. So it's difficult to measure precisely the biodiversity because, like we saw earlier, scientists have not discovered all of the species on Earth. And if you think about how, large our Earth is, it would be very hard to. So what they do is they kind of take an estimate and they look at kind of the area around there. They look at the, the abiotic, biotic factors, looking at the temperatures, the amount of rainfall, the amount of sunlight that they get throughout a whole entire year. So as we look at these types of examples, you know, a coral reef is going to have lots of biodiversity because, of course, what it has to offer. The waters are warming, there's lots of sunlight, lots of coral, which is then giving places for the organisms to live. You know, same thing with those tropical rainforests, high biodiversity. Areas where we're going to see low biodiversity, less living organisms, we're going to find in the desert. You know, it's hard. The conditions there are going to be tougher to survive in. So these organisms, you know, they're working with drought, you know, not having water. If we don't have water, organisms aren't going to be able to survive. Their, you know, cell processes can't take place. There's no photosynthesis. Plants aren't going to be able to make oxygen, take that carbon dioxide out, provide sugar for other organisms. Same thing with areas like in a tundra. This area, you know, thinks it's only kind of thaws out for a few months of the year, whereas in the rest of it, it's going to be covered with snow and ice. Okay, so talking about measuring biodiversity. Let's move on to why biodiversity is important. So biodiversity is vital for supporting all life here on Earth. How's it going? It provides us with all the food and many industrial products and medicines. So as we think about it, not only are we consuming, thinking about using these species as food, but we also, you know, we make things from it. You know, as we think about, you know, the paper that we use, coming from trees, you know, think about the materials that make up our house and products that we use, okay? And the big thing is medicines. These medicines come from plants, and it also comes from other species like bacteria that we can get medicine from. And that's kind of goes into that important piece is, you know, why biodiversity is so important is we're thinking about scientists saying, hey, we haven't discovered everything. Maybe, you know, we keep finding new species, and maybe we can find, you know, a cure-all to a particular, you know, type of cancer or disease that, you know, humans might face or other organisms are facing. Biodiversity also ensures clean water, air, and fertile soils. It provides opportunities for recreation, tourism, scientific research, and of course, education. It's also a source of cultural identity for many, we'll say in this particular different groups like Australians. Biodiversity is the foundation of healthy, functioning ecosystems, which all life depends upon. So again, we're talking about this whole connected piece, and it's all related in together. So here's a good old list of, you know, why having all of this biodiversity is so important. You know, we can think about having all these different species of life, but every species is important in its own way. It provides something to that ecosystem, and we can't replace it. Okay. Okay, so what are some threats or why we're concerned about protecting biodiversity or why we're losing biodiversity? And scientists came up with this kind of acronym called HIPPO, and an acronym is just kind of like an abbreviation to use it for it. So when we think about HIPPO, we're talking about habitat destruction, invasive species, pollution, population, and over-harvesting. So these are the major threats to biodiversity, what is our concerns are, or what is taking away the biodiversity here on Earth. So we think about habitat destruction, you know, big one. Think about deforestation. Humans are going in there, cutting down forests, taking out forests so that we can, you know, lots of different reasons. One, build. One, we need those materials so that we can have more, we can make more, we need the timber so that we can make it, use it for products that we use or, you know, lumber for houses, okay? But in doing so, as we're clearing out those areas, it destroys the soil. And we think about all the things that live in that soil. There's little microorganisms, there's bacteria that live in that soil. We take that away, you could say like, oh, we'll just rebuild the trees. Well, when you take it all away, the soil is not going to be very fertile, so it's not going to allow for growth to occur as easily. You also think about, you destroy that habitat, all of those organisms that were living there no longer have a place. So they either, move on to someplace else, but then they have to fight in for, competition. And so they end up, of course, not surviving. Invasive species. Have you guys heard this word before? Invasive species. Maybe if you haven't, think about the word invasive, if somebody's invasive. Okay, invasive, or what we also call introduced species, have caused many native animals and plants to become extinct across the world. So introduced species, these are an invasive species, or an introduced species is an organism that's not native to the area. And it means it's been brought in somehow. And this can occur from, being transported through, like on a ship, the species gets taken in, or, humans taking these species and trying to put them into a new location. So it's introducing these species that shouldn't be there to a new area. And what's happening is they tend to wipe out the organisms that were living there. And so it's a negative effect on the economy, our environment, and our health. Okay. Here's a little example. This was a while ago, 1859 in Australia. 24 rabbits were introduced for hunting. And the rabbits, they bred really, really quickly. And they didn't have a lot of predators. And so they just continued to produce and produce and produce, that whole continent was just covered with these, rabbits. They took over the resources. They took over the habitat of those native species. And now those native species that were there, like they give the example of the bandicoot, is now endangered. Okay. Pollution. Pollution contaminates the natural environment with harmful substances produced by human activity. We're going to hear this a lot. So we're going to hear humans being the cause for these. An obvious example of pollution is, say, an oil spill. This happens when oil is released accidentally into the sea from a tanker, pipeline, refinery. The spill forms this thin layer of oil called a slick, poisoning the sea life, damaging the fur, feathers of seabirds and mammals. Due to the contamination, the atmosphere in the cities, most of the animals ran away in search of an appropriate place to live in. But, of course, then we go back into moving into another area, competition, they're not going to survive. Let's see, population, the other P. So we think about our populations continue to grow and grow exponentially. The growth of human population is the biggest threat to the natural environments today. There are over 7 billion people in the world. And when you think about it, there's not enough room for all of these people and all of our environments and all the other species to kind of coexist when we have people they're kind of taken over and not thinking about it kind of worldly and trying to conserve. Okay. So as we think about it, we go back to that phrase of survival of the fittest, and animals and plants getting crushed, getting kind of being pushed out because of human consumption. And the last one here, our O, we say over-harvesting or over-exploitation. And what that means is that humans are being over-harvested. We're taking more than what should be taken. So you think about it, the species are being taken or used more than they can reproduce. And so we can end up, putting them in danger or causing them to become extinct. Okay, so a little blurb in here. Species are being over-harvested. They're being used faster than they can be replaced, which is likely to lead to decline and extinction. We think about, fish. Cod is now too rare to be caught in many areas off the coast of America. Same thing like here in Washington State. We have lots and lots of laws about, fish and wildlife and what you are allowed to, hunt or fish. And, it's like every year the restrictions are getting tougher and tougher, and people aren't able to, consume or fish recreationally as much as maybe in the past. And, it's a good thing to have those protections in place to help slow down that process. But it's showing that humans have overconsumed, overharvested. We've had an effect on these other species. Okay. See, plant species can also be easily overharvested. Brazil nut tree might be in danger of extinction because not enough of its nuts are being left in the rainforest to grow into new trees. So you think about it, humans wanting these products, wanting too much of these products, thinking like, oh, it's fine, but then they keep consuming and consuming, and then the species don't have, we don't leave enough for these species to then reproduce and keep that population going. Which is sad because that leads to extinction. Now, extinction is when all the species of an organism die. There's no more. Once an organism becomes extinct, it will never come back. So we've heard of, organisms that once lived before. An endangered species is a species that is in immediate danger of becoming extinction, and all actions need to be taken to protect them. As many as 30 to 50% of all species are possibly heading toward extinction. So as we think about more of going back to that hippo, pollution, habitat destruction, overpopulation, overexploitation, harvesting, we're taking too many of these species. 99% of currently threatened species are at risk from human activities. So we think about the biggest driving force for extinction, our biggest cause, is humans. Kind of sad to say. But again, as the more we talk about it, the more that we become aware about it, the more we can protect these organisms from extinction happening. Okay. So we think about threats to biodiversity, the number one threat being humans. And the reason for extinction, like we talked about it, the biggest ones: habitat destruction, pollution, human overpopulation, invasive species, and climate change. So you've probably heard about this with the polar bears, as we're thinking about climate change taking place due to humans. So we're producing more carbon dioxide, which is going up into our atmosphere, causing the Earth to get warmer. These areas, these polar Arctic regions, are getting warmer and warmer and warmer. These small changes, very small increase in temperature, causes the ice in the Arctic to melt. And we think about organisms that live in these habitats, like the polar bear, we're ruining their habitat. Little blurb here reminds you guys about what climate change is. It's quickly becoming the biggest threat to the survival of Earth's organisms or biodiversity. Climate change refers to any significant change in the measure of climate lasting for an extended period of time. So again, this could be getting warmer or it could be getting colder. We know, as you can see in these pictures, our temperature is rising. We're talking about small rises, but again, that 2-degree difference has huge impacts on the systems of the Earth. Okay. Average temperatures of the last century have already increased to more than 1 degree Fahrenheit. Scientists have concluded that most of the absorbed warming is very likely due to the burning of coal, oil, and gas, also known as fossil fuels. Okay, so when we burn those, we get what we call the greenhouse effect. The greenhouse effect naturally keeps our planet warm enough to be livable. So we think about our atmosphere. We got this nice bubble around our planet, and it's this perfect bubble, perfect screen that allows sunlight to come in and keep our temperatures perfect here on Earth. Not too cold, not too warm. But what happens is human activity, we're burning fossil fuels. So we're burning that coal, oil, and gas. We're driving our cars. We're producing, using oil and coal in factories. Okay, and that then gets emitted up into the atmosphere. Now, these types of chemicals, it's like they grab onto the heat, the sun's heat, and they don't let it escape out. So we're trapping more and more of this heat in our atmosphere, causing the temperature to increase. Okay, in this unit, it talks about, this kind of covers the whole kind of last section there in biology semester 2. And I just threw in some of the questions that I kind of found were kind of the trickiest ones. So when we think about what a population is that all the members of a species living in a particular area at a particular time, all the organisms in an area, all the species on Earth, or the number of people. And I put this one in there because people get confused on A and B. And it's not all the organisms in the area, but it's a population is all of the species. But we're talking about species that live in that particular area at the particular time. So we're not talking about other species of organisms. And we're not talking about, 2,000 years ago. A population refers to one species, all of them, in one area at one time. Rainforests have low biodiversity. So when we think about where we find large amounts of biodiversity, so where are we going to have the most variety of life? And it's a true and false question, and the answer is false. Rainforests have a high biodiversity. They actually have the highest biodiversity in an area. So this is a false question because rainforests, again, have high biodiversity. Lots and lots of variety of life live there. Populations of organisms only interact with themselves. Is that true or false? That is false, correct. Yep. Populations of organisms interact with everything around them. They interact with the biotic and biotic factors. So they're interacting, with the soil and the ground. They're breathing the oxygen in the air, drinking the water. Okay. So populations of organisms interact with themselves, but also everything around them. So that is a false statement. What does HIPPO stand for? Habitat destruction, invasive species, pollution, population increased, and B, overexploitation. So again, that's that overharvesting, using too much of the species or of the product without giving it a chance to replenish itself. Biodiversity is important because it helps with providing medicines, soil formation, clean air, all of the above. You're right, it is D, all of the above. So we think about it, from all of the variety of life that we have, we get medicines. Think of the bacteria, we can get medicines, plants, we can get medicines from them. Soil formation, so those organisms and bacteria, microorganisms, all creating this soil. When we have rich, fertile soil, we have more life. Plants can grow. You think about clean air. All of those producers, plants, they're going through photosynthesis, taking that carbon dioxide in, producing oxygen for us. So all of the above. A blank is an organism that is not native and has negative effects on our economy, our environment, and our health. It wouldn't be extinct because they're not around. It is invasive. So invasive or introduced species are organisms that are not native and have negative effects. Extinction can be caused by humans. Or extinction can be caused by human population, habitat destruction, pollution, all of the above. So again, another one of these, all of the above. So yes, we think about extinction caused by humans, yes, and all of these different things. Overpopulation of humans, humans destroying the habitat, pollution caused by humans. And humans are caused for the most extinctions today. That is true. So you can see in some of these questions, like I had said, I kind of want to hit on this theme. We think about threats to biodiversity, threats to our planet, threats to extinction, human caused. So we need to think about our actions and what we're doing on our planet and how we can, stop it from being so, having so many negative effects on other parts of our planet, like other species. The burning of fossil fuel, that's that carbon, producing carbon dioxide from burning oil, coal, and gas, produces an increase in CO2. So carbon dioxide increases, which leads to an increase in temperature from the global warming, from the greenhouse effect. Biggest threats to biodiversity, we're looking at climate change caused by humans, which is true. Okay, so I put those questions in because a couple of them were a little bit tricky and I wanted to kind of go over the wording for it. Okay, so that was my spiel there on biodiversity. I want to open it up to questions that you guys might have, maybe on a topic, this topic, could be on another topic, another class, or an assignment activity. If there's anything that you're here to get answered, this would be a great time to do so. Just gonna give a moment, so if you want to chat, if you want to speak, you're more than welcome to do so. And if not, then I will go on to my last little part talking about discussion posts. Okay, well, at the end of the session, I'll open it up for questions again. So think about it. Please feel free to ask questions, you guys. I'm here to help you. Okay, so let's get to discussion posts. At the end of every session or every kind of semester here in science, if you're taking biology or earth science, you're going to get these discussion posts. And sometimes it'll, they're kind of reflective, and they're also asking for your opinions. And so you're going to see this throughout, the courses. Why do we have discussion posts? What's the point of it? Discussions allow us to share our thoughts, ideas, to then come and make a solution. What's important about discussion posts is, if you think about it, it's not just one person. When we think about the word discussion, it's a group of people, and we're all different. Therefore, we're all going to think differently, and we're going to have different viewpoints or ways of thinking about things. And what's great is that somebody might point something out that you never thought of or never looked at it that way. And that's kind of the point of discussion. We listen to others. It helps us see thoughts, ideas, reasons, solutions that we might not have thought of. Or maybe we have this great idea and we throw it out there, and somebody says, okay, well, did you ever think about this side of it? So again, having this kind of variety, diversity in people, in their minds, the way they think, the ideas that they come up with, pros and cons, different viewpoints, helps us create this more meaningful, more effective solution. Okay, so in the end of semester 2, you get a discussion post on changes to the environment. And it says, in this course, you've learned about factors affecting environments and biodiversity here on Earth. In this discussion post, please share your thoughts on what is the most significant factor causing this. What role do humans have in protecting or changing this issue? What are steps or plans that you would implement? So as we look at, okay, how do I address this? Okay, they're looking for you to share your thoughts on what is causing threats to biodiversity and threats to environments here on Earth. What role do you think humans play in it? And what would you do to help protect it? Let's get to the rubric here, okay? You do get a rubric that kind of gives you a scoring guide, because I want you to see that it's not about the right or wrong answer. Again, it's a discussion post, so it's asking you to share your thoughts, okay? So there's not a right answer and there's not a wrong answer, but you use this rubric to make sure that you hit the requirements. So again, the rubric shows what you need to do, okay? So we have a 3, 1.5, and a 0. So thinking about point value, full points is going to give you 3, half points, and no points. So if you do nothing and you leave it blank, you're going to get a 0. Okay. So the 2 parts here that they are asking you to look at is they're looking for you to explain the role of humans, and then steps for action. Those are the 2 kind of requirements or parts to this discussion post. So again, you're not graded on what you say. You're graded on, did you meet these 2 requirements? Did you explain your ideas, your thoughts for these 2 groups? So to earn the full points on the first category, they want you to give 3 sentences with an example that refers to the factors causing changes to the environment. So what do you think humans are doing that are causing changes? You could say, we are driving too much, which is producing more CO2. We're burning fossil fuels. That's a specific example. Okay, and then you can see if you maybe only give 1 to 2 sentences, you're going to get less points. So the more descriptive you are, the more points you're going to get. The other thing is then the second part, steps for action. 1 or more ideas for action are given. So it says here, what steps or plans would you implement? So what would you do to help change that? Would you, restrict driving times? Would you, lower the emission rates? What kind of ideas do you have for humans to start kind of taking action in protecting our environments and biodiversity? Okay, so again, it doesn't say student got the right answer. Again, it's looking at, use the rubric. Did you meet these 2 points? Okay, and then I gave you a couple examples here from some students. This first one here, I believe humans are the cause for most of the bad things on Earth, making things change due to us using gas, making garbage, etc. So there's one, they are talking about examples on how we are hurting our environment. Second part here, we should switch to more environmental friendly things to prevent global warming and more. So they came up with an idea. Now, when we look at this one, we could say, okay, maybe give, thinking about scoring, they said we should switch to more environmental friendly things. It would be better if the students, instead of saying switch to more environmental friendly things, give some examples. Like, are you talking about, using more different types of vehicles that are, low emissions, using electric cars, hybrid cars, is that what you're talking about? Using different types of, light bulbs and energy efficient appliances. Okay, so I think with this particular one, they got both parts, but maybe add a little bit more detail and explanation into it. Another student, humans polluting the earth is the main factor for global change, therefore leading to lower biodiversity. So again, they put in there what their reason is. Humans pollution, they believe, is the main factor in driving that climate change. So pollution, they didn't specify, again, but you could say pollution causing that climate change. So we're talking about air pollution. Humans, and then here's their plan or their thoughts. Humans need to start taking better care of the earth. For example, practice correct ways to dispose of waste. Maybe reduce, reuse, recycle. Oops. One more. I believe the biggest hindering factor for biodiversity is humans burning fossil fuels and destroying more and more land by the days. Humans are the only one that can help this issue by making green patches, making hunting reserves, burning far fewer fossil fuels. If I were allowed to implement change, I would try and convince more countries to cut back on fuel consumption. This is a great post because we saw those 2 points and we saw them with more detail, okay? They gave examples, burning fossil fuels, destroying more land, and then they gave ideas on what they believe should be done or implemented to reduce that effect. So this is full credit one as we're getting more examples and getting more detail into those examples. Okay. So again, as you're moving forward and you're thinking about, how do we do these discussion posts? And some of them are reflections like this one, where it's asking you to give your ideas and then what you would do to implement. Some of them are asking you to respond to another student. Do you agree? Do you disagree with them? But again, we're not looking for, as you can see, going to these scoring guides, there's no right or wrong answer. It's explaining your thoughts and backing them up. So check out the rubrics when you are using this. Okay. Okay. Does anybody have any questions about discussion posts or questions about any other science? So this would be open up if you have a question again about your courses, where you're at in your studies, a particular assignment. Okay, we are doing, now we're doing 2 science live sessions a week. Mine will always be here on Thursday at the same time. Again, your teachers, all of your teachers are here to help you succeed and help you meet your goal. Okay, so please don't ever feel frustrated. If you are stuck on a question or a concept, please reach out to your teachers. Send them an email, send them a chat. Sometimes you just need somebody to, say it in a different word. Explain it just a little bit differently, and it makes that click. Or, you're not sure how to do an assignment. Just send a quick question. Hey, can you explain, what exactly I'm supposed to do? We never want you guys to get frustrated. We want you to keep going, be able to continue getting through your courses and completing them. Same thing if you have ideas for topics. If you're stuck someplace, or next week you're going to be working on, food chains or the carbon cycle or something like that, and you would like to see a live session on that, please let me know so I can, plan for that as I'm thinking about, what I'm going to do next week. I would love to get feedback from students saying, hey, it would be really helpful if you did a session on this. So I want to be, I want this to be helpful for you guys in your science course. Okay. Okay, then, well, thanks for joining. Have a great day and good luck in your courses and keep it going. Have a good one.